Hello everyone, welcome back to my channel. Today I'm going to give you some important tips on SN2 reactions. So theoretically, many of you know what is SN2 reaction and SN1 reaction, but in the lab, research lab, we always do uh, many kinds of SN2 reactions, and it is very common in the lab. So there are some things you need to remember during setuping the SN2 reactions. So I was thinking let's give some tips on that SN2 reactions, because if you fail to follow those tips, many times your reaction will be failed and ultimately you will lose the product. Starting material yield will be very low, sometimes give a mixture of many things. So let's see a little bit about SN2 reaction, and I will not go details on it because I have planned to make a video on SN1 and SN2 reactions, like a theoretical knowledge. I'll bring it back later, but now I'm gonna just tell the tips for that reaction uh, to maintain during setuping the SN2 reaction. So let's see what is SN2 reaction. So this is written as like SN2 substitute nucleophilic substitution second order. Okay, and there is SN1 that is called nucleophilic substitution first order. So more or less all of you theoretically know SN2 reactions. So suppose you have a carbon with halogen, suppose bromine or iodine or whatever, and you have this carbon, two hydrogen, and maybe you have more carbon or something like as another group, or suppose this. So this can be act as a R, like alkyl group, two hydrogen and alkyl group. So SN2 reaction normally happen mostly favored in like primary carbon, like which is not secondary or tertiary. What is secondary? Secondary carbon is like if you have two carbon and have bromine and one hydrogen. So this is secondary. What is tertiary? Like suppose you have CH3H. So it is secondary. And what is tertiary? Suppose you have a carbon CH3, CH3, CH3 and bromine. So it is tertiary carbon. So it shows like 3 degree or tertiary carbon. This is secondary carbon, and this is 1 degree carbon or primary carbon. Okay. So these SN2 reaction always favor in primary carbon. And what happened actually in this SN2 reaction? So if you put base, normally there are many kind of bases available. So normally base act as a nucleophile. How? Why it is called nucleophile? Because this carbon and bromine, so this bond contain two electrons. So bromine is more electronegative than this carbon. So electron density try to go there. So it make like partially delta negative, and this carbon form partially delta positive. So this carbon has less electron. That means it will act as a kind of nucleus, like nucleus is like always positive. And the thing which love this nucleus, that is called nucleophile. So suppose if you have any base, or like in short people say N minus, Nu minus, like nucleophile having more electron, that's why it is a nucleophile. So these negative electron can attack from the back side of this carbon, and these electron can go to this bromine, and ultimately this bromine will be kicked out, nucleophile will attach in this position. So this is actually SN2 reaction. For nucleophile there are many options, especially if you have a base, suppose OH minus, a strong base, sometimes weak base also can act as a nucleophile. You can add iodide ion, that is also one nucleophile. You can use cyanide ion, that is also a nucleophile. Sometimes you can also use OR minus, so that is also like nucleophile. there are many other things like potassium t-butoxide, like oxygen, carbon, another carbon, another carbon, another carbon, like suppose CH3, 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 and this is one carbon. So if you use O minus K plus, so this is called potassium t-butoxide. So this potassium t-butoxide can also attack here, kick out this bromine, something like this. So sodium t-butoxide. There are many other options. It can be used for the SN2 reaction. Now you can think like how it happened. And for SN2 reaction, remember one thing, stereochemistry, like since the nucleophile or base attack from the back side and this bromine is gone, so it goes like inversion of the stereochemistry, it inverted. So once the product is done, so the carbon will, you will see like this, so base will go to the other direction, so there will not be negative, so base like this. So that is called inversion of stereochemistry, because that attack from the back side of the carbon. And how it happened, so when the base attack this carbon, so it will not immediately kick out the bromine or bromide ion, so this form a transition state, that called transition state. So you can show this carbon like this. So the base negative electron, so it is forming partial bond here, and the bromocarbon bond partially breaking here, and this is called transition state, TS. So sometimes transition state show like this. So once this transition state is formed, then the bromine will be like bromine will go out, breaking completely, like detaching the relation from the carbon, and bromine, the nucleophile or base will make a bond. So ultimately your product will be this carbon, base, hydrogen, hydrogen, and this R. So inversion of the stereochemistry, like backside. So you can assume like suppose you're walking in the rainy day with like wind, strong wind, and you are using the umbrella. So umbrella is like one form, and suddenly the wind inverted your umbrella, so the product will be like inverted umbrella. So that is always like very common and traditional example for SN2 reactions. So I know all of you know these chemistry or basic thing, but when you are setting this reaction in the lab, research lab, there are a couple of things you have to remember before setuping. So let's talk about that. And please subscribe my channel MHCHEM if you don't subscribe yet. Whoever subscribed already, thank you. Okay, so what is the application of SN2 reaction? In many cases, people use SN2 reaction to make ether type compound. How? Suppose you have phenolic hydroxyl group and you want to make like ether, OR. R means R can be like long chain alkyl group, or like PEG chain, like PEG polyethylene glycol chain, like this, or some other things, like it could be also like long chain alkyl group, and at the end it has a ester group. So this is very common to make this kind of ether by doing the SN2 reaction. So now let's see how it can be made. Suppose take an example, like many times people will do benzyl protection in like phenolic alcohol somewhere. So like you have to use benzyl group here. So that is called benzyl protected things, whatever other things you might have. So that benzyl protection can be done by SN2 reaction, okay? And also there are some other example, like if you take fluorine molecule, fluorine means like this. It is not making ether, but these two hydrogen are so acidic, so you can put alkyl group here, both like two alkyl group here. So that is also SN2 reactions. There are lots of example in like literature for the SN2. Suppose you want to put a hexyl group here, 1 2 3 4 5 6. So here also like two together, like 1 2 3 4 5 6. 1 2 3 4 5 6, two hexyl group. So first you have to use a kind of base to remove those hydrogen to form a negative ion here. Like first one proton will be removed, negative ion, one alkylation happen, then again you have to add more excess base, then these hydrogen will be gone, then there will be another negative charge, and then there will be another alkyl group. So for this actually you have to use hexyl bromide, like 1 2 3 4 5 6. So you have to use, yes, hexyl bromide. So this carbon actually acting will, this carbon will be acting as a electrophile, because once you put the base here, like if you use potassium t-butoxide, then one of the proton will be gone and it will form a negative ion here. So this is now will act as a nucleophile. So this will attack, this negative ion will attack this carbon and bromo will be kicked out. So one alkylation will be happening, another hydrogen will be there. And if you use extra base, more base, then second proton will be gone again. So once first alkylation is happening like this, then second proton will be, can be removed also by additional base. If you use excess base, then it will form another negative charge, and another molecule of this bromo compound will be attacked by this negative to this carbon, and another alkylation will happen. So this will form dialkylated fluorine molecule. So this is one kind of SN2 reaction. And mostly like hydroxyl group, phenolic hydroxyl group, you can put benzyl protection, you can do alkylation having some other functional group, long chain. You can put PEG compound or like polyethylene glycol type compound having like good living group, like tosylation. Like if you have tosylated compound like this for polyethylene glycol like this, so if you want to connect this part with here, like to make an ether type things, so you can easily do by SN2 reactions. So there are many things can be done with the SN2 reactions. Now, what are the tips or what are the things you need to remember before setting these kind of SN2 reactions? Let's talk about the benzyl protection. Very simple reaction, SN2. Now, what are the things we are going to use and what are the important tips for these kind of reactions? First of all, your starting materials should be very pure, like anhydrous, no water in it. Okay, so whenever you suppose you have something you make in different synthetic step, now you have OH group and for some reason you have to do the protection. So in that case you synthesize that molecule, so make sure that it is dry enough, like completely dry. Okay, first thing first. And benzyl, you can use benzyl bromide or benzyl chloride, but remember, you already know the bromo is good living group than the chloro, because because of the size of the atom, like electron affinity through the nucleus or something, many other things, you know. So preferably people use benzyl bromide for the protection because these react faster. But important thing to remember, this benzyl bromide is lacrimotor. Lacrimotor means like if you somehow get some exposure of this compound in your eyes, immediately you will feel burning sensation and you will cry. So careful. That's why when you take this compound, how to measure this compound. So first calculate the amount you required and check the density of this molecule. So suppose you know the density D equal to M over V. So um, we can write M over D. So suppose you calculated your required amount, mass, like as a gram, okay, and your density, convert the density in a gram unit, like CGS unit, then you divide this required mass with the density, then you will get the volume, how much you take or how much you need. Then you can use syringe, you can take that compound directly from the bottle with the syringe inside the hood and immediately you can add. So that's why remember this is important not to expose outside because other people also can be affected. But if somehow you get this like in your eyes or something, use eye washer or like plenty amount of water in your eyes. Make sure that you are feeling comfortable, and if it is too much then just go to doctor and check with the doctor. So that is a safety thing for the benzyl bromide. And not only that, try to use this benzyl bromide as anhydrous as possible, like dry, no water should be there. Like if you know, like if it get water, so that bromide will be kicked out by the water and ultimately it will form the benzyl alcohol and your reaction will not be successful and you will get less product. So it is also true for the chloro one or any other halide type or pseudo halide, like tosylate is a pseudo or triflate is a pseudo, like in many cases you can think those can be like affected by the water, so there shouldn't be any water. So this is like these are like for precaution for two starting material. Now for the solvent case, so very commonly for SN2 reaction people use THF, like tetrahydrofuran, THF. So that THF should be super anhydrous, like super dry, like THF always has a tendency to go like to get the water. So try to use very nice super dry or anhydrous THF for these kind of reactions, especially for SN2 reactions. If somehow THF gone bad, then your reaction will go bad. You will get less product for this kind of reactions because from the water from the THF will destroy the your alkyl or like bromide compound or halide compound, and also it could be problematic because why? This can be also affected by the water from the THF or like any other source from the THF. Not so how? Because when you use base, suppose in this case, you can use simply potassium carbonate. Okay, so ultimately you will make your phenolic hydroxyl group as a phenolate. Okay, you might produce potassium phenolate. This phenolate, sorry, this is a positive. So this phenolate ion then will this benzyl bromide, this phenolate ion will act from the backside of this carbon. Okay, so if you have any water in the system somehow, very trace amount of water, that phenolate ion can be also destroyed. And not only that, these kind of reaction should be completely oxygenless, like deoxygenated. So before setting the reaction, definitely do the degassing, like there shouldn't be any oxygen because that oxygen also, molecular oxygen also can destroy your nucleophile and also can destroy your this um, uh, what is it called, like alkyl halide compound. So that's why the solvent is very very important, like it should be anhydrous, dry. And so this reaction, normally, as I said, people use THF for the many of the SN2 reactions, but for specifically this reaction you can use acetone in potassium carbonate. So you it should give you this compound, like the this benzyl protection very quickly. But remember again, this acetone also should be anhydrous. So now, in many cases, people use THF, acetone, and also like toluene. Some people can use DMF, like dimethyl formamide, or DMA, dimethyl acetamide. In some cases, people use DMSO in many cases. So whatever the solvent they are using, make sure that all are anhydrous dry. Some other solvent also from the literature you can find, but mostly THF, acetone, this kind of solvents are used for the SN2, this kind of ether making reaction. So now you know about the starting material like phenolic hydroxide group, what happened with the in presence of oxygen or water, and also like benzyl bromide, what about the benzyl bromide, and also like how this can be affected by the water or oxygen. So make sure before setting the reaction you remove all the oxygen, you are using all the dry solvent. And also the potassium carbonate, you can keep the potassium carbonate in a vial, glass vial, in the oven for overnight, and then next day do the degassing while it is hot. So you will get the dry potassium carbonate. Potassium carbonate is okay to keep in like 85 degrees Celsius in the oven. So once it is dry, then you can use this potassium carbonate is dry, acetone is dry, or like if you use THF, THF is dry. Some people also use dry solvent or anhydrous solvent. So I preferably do first time like potassium carbonate and acetone, because those are easy to work up, like handle after reaction is done. But DMA, DMF, if you use DMA and DMF, so you have to use lots of water wash, because those are high boiling solvent and it is not easy to remove through the rotoweb. So remember that, like if you have DMA or DMF, like dimethyl acetamide, or DMF like dimethyl formamide, so you have to dissolve your crude or compound in a ethyl acetate or like DCM, whatever soluble. Use that one and add water, extract, do separate funnel, shake it and remove the aqueous part, again add water, do it like 6, 7 or 8 times even. So still you might have trace amount DMF or DMS, so like you will get your product as like gummy material, even if you think like your compound should be solid through the literature or any other source. But because of presence of trace amount of DMA or DMF, your crude could be liquid. It's okay, like sometimes it is easy to purify with the column, like just run with the hexane, immediately the first solvent will be gone, then slowly you can come up with your product. But sometimes it is too pain, like to remove the DMA or DMF and working on that. That's why use THF or acetone, like or easy solvent which has low boiling point and easily washable, like easily gone, like with the rotoweb. Another important tips I can give, like if you have the high boiling solvent like toluene or like DMA, DMF, you can do sometimes also add hexane in the crude mixture and do rotoweb couple of times. So hexane will reduce the boiling point of the high boiling solvent by azeotropic mixture, by making the azeotropic mixture, then you can easily remove your solvent, high boiling solvent. So here, so let's show how you can set up these reactions. So you can take one 3-neck flask, put rubber septa here, and another rubber receptor here, and attach your condenser, because sometimes you need to heat your reactions. Attach condenser here. So close this cap with a rubber septa and put a needle with a line, and release this line in a well bubbler. So your well should be immersed with well bubbler. So whatever the gas pressure produced, it will be gone through the well. And you can also keep something here like to close or control this well bubbler, and put one gas line through this, like whether it can be argon or nitrogen, inert atmosphere, and degas it couple of times with this line. Definitely if you have double manifold, you can use degassing. In that case, do not attach this first. While this system is closed, this system is closed, and this is closed, so do not attach it. So you can put gas and degas, gas and degas. So once it is done, then open this rubber septa under argon, flow of argon or nitrogen. Okay, then you can add all of your solid starting material, and you can add your liquid starting material, and then close quickly and degas again, and then under argon again, through this, put the rubber septa, through this rubber septa and needle and syringe, you can add your solvent. Okay, once it is done adding the solvent, then you can add your liquid reagent through this rubber septa again. So once it is done, then keep this argon or nitrogen gas line like positive pressure, little bit positive pressure, and then you can open this knob or you can connect this line to the well bubbler, and then you can definitely, you will start water. If you have to heat, then start water in the condenser, and then if you have the well bath or like sand bath, whatever the heating source you have or heating mantle, then start heating. Okay, start heating. So your reaction will be done, and follow the reaction procedure. What is the time you need to do? One important thing I can tell you here. So suppose for that specific reaction, if you want to do the phenolic hydroxyl to like benzyl protection, so in that case, when you use potassium carbonate, so in that case my suggestion will be first use solvent, first use this phenolic compound in the flask, take this as a solid, degas it, and then also potassium carbonate is a solid, add that one and degas it again, like give vacuum and put gas again, and carefully do not keep in under vacuum for a long time, because those could be like powdery solid or something, it can go. So just quick degassing, and once those two are added, then add the acetone and stir for like 10 to 15 minutes, because give it time to make this phenolic hydroxide to phenolate, make it nucleophile first. So this once it is formed, and since you already have one like 3-neck flask, so once it is formed, then take your like the benzyl bromide in a syringe, and use slowly dropwise. It will give you a better result than the normal. Because why? Because once your nucleophile is formed and you are adding slowly the bromo compound, so it will, these nucleophile will get the bromo compound, immediately it will react, bromo compound, immediately it will react. So that's how all of the bromo compound will be used up. But if you add all together, start reacting, so some of your bromo compound will be destroyed by the other base in the system. Not potassium carbonate may not be the strong base, but if you need to use some other choice of base like potassium tibiotoxide, sodium tibiotoxide, in that case some of your bromo compound can give you the eliminated product. So what is this eliminated product? So like suppose you have this bromo hydrogen like another carbon, whatever. So with the presence of bromo, so first that bromo will be kicked out, and with one hydrogen will be kicked out. So ultimately it will form a carbon-carbon double bond, like uh, this kind of eliminated product. So that's why always try to use your halide compound, whatever liquid or solid. If it is solid, dissolve it in your solvent, same solvent, reaction solvent. Like if you are using acetone, so dissolve your compound in acetone. If you are using THF, dissolve your compound in THF if it is solid, the halide compound. So dissolve it and take with the syringe and add slowly dropwise. But if you have the liquid compound, still I would do the same thing, like add little bit of your reaction solvent, add it there carefully, and uh, mix it under inert atmosphere, and take the solvent from the that system where you dissolved it with the syringe, and immediately insert in the reaction and slowly add dropwise, and let the bromo compound chance to react with the nucleophile. So I hope this whole video or whole discussion will help you a lot to understand your SN2 reaction setup and SN2 reaction setup in precautions, and also you will improve your synthesis for your product. So thank you for watching my video, and please subscribe my channel if you didn't do it yet, and whoever subscribed, thank you very much. And I'll bring more chemistry video and synthesis and tips, like mechanistic video. So till then, stay fine. Goodbye now.